A piston goes up and down inside of a cylinder, and there's 4 to 8 thousandths clearance between the piston wall and the piston itself. Well, in that 8,000 clearance, there's a little bit of activity for the piston to go like this before the clearance. And one of the problems a lot of people experience is that the bottom part of the piston, which doesn't have a wear surface like a ring, will scuff on the side, and it'll break down an oil barrier of an average oil. The one thing we notice when we run the AMSOIL is we don't have that scuffing on the piston, and by not having that, we have the full width of the piston going up and down. We lose that going back and forth, which is horsepower robbing. Well, if you take a connecting rod and the bearing and the piston as an assembly, that thing is going up and down 9,000 times every minute. So that means things is stopping and starting 18,000 times every minute. You can imagine the load on a bearing. That's why you need that extra protection, and you need it on both the top end and the bottom end so that you don't break a bearing. It's not so much not only losing the friction reduction, but the initial impact, and where the oil actually acts as a little bit of a cushion on the load of the bearing itself. It seems like year after year, tolerances get tighter, motors get more towards the ragged edge. Everybody continues to look for that little bit of advantage. And when you live by the sword, you die by the sword. With us running the AMSOIL, we haven't seen any oil-related failures at all. We've seen a couple mistakes that we've made on ourselves, leaning down the fuel-air ratio to try to gain a little bit more, or when we first go out to test for some altitudes, we'll maybe find that edge and go beyond. It's more of a fuel-air mixture that we self-create, but the oil lives day after day.